Example number 7 has us identifying linear functions by graphing. Fernando uses a garden hose to fill his empty pool. The table shows the amount of water in the pool after every 5 minutes. So here's our table. We have 5 minutes, 60 gallons, 10 minutes, 120 gallons, 15 minutes, 180 gallons, 20 minutes, 240 gallons, 25 minutes, 300 gallons. So the first thing we want to do is we want to determine linearity. Can the numbers in the table be modeled by a linear or nonlinear function? Check to see if the change for each equivalent interval in the table is the same. Assuming that the pool is completely empty when Fernando turns on the hose, the amount of water in the pool increases by 60 gallons during the first 5 minutes. It also increases by 60 gallons during each following 5-minute interval up to 25. Because the change in the amount of water is constant for every equivalent interval of 5 minutes, the numbers in the table can be modeled by a linear function. So we've got our time and our water, 5, 10, 15, 20, 25, 60, 120, 180, 240, 300. To get from 60 to 120, we increased by 60. 120 to 180, we increased by 60. 180 to 240, we increased by 60. 240 to 300, we increased by 60. So we have a constant rate of change between each of our intervals. And as you notice, these intervals are all the same as well. We're increasing by 5 minutes each time. Or he waits 5 minutes to check each time. Part B is to look at the graph. So you take each of your points, the 5, 60, 10, 120, 15, 180, 20, 240, and 25, 300, and you plot them onto the graph. The points on the graph can be connected by a straight line because we can have time in between each of the 5 minutes. Right? We could check at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on and on. So therefore, they can be connected by a straight line. So this gives us a linear function.